This is Module 9 entitled Address Resolution. In this module, we are to talk about ARP, Address Resolution Protocol. We'll compare the roles of MAC address and the IP address and describe the purpose of ARP and describe the operation of IPv6 neighbor discovery. MAC and IP. There are two primary addresses in an end device. That's the MAC address or the physical address, which is a layer 2 address, and the IP, which is a logical and layer 3 address. So again, the MAC address it's embedded in the LAN card, while the IP is set up by the user or say the administrator. The moment that a computer, a sender, sends data, the data is being encapsulated by a source IP address and MAC address and destination IP address and MAC address. And when the destination IP address is on a remote network, the destination MAC address is that of the default gateway. ARP, on the other hand, is used by IPv4 address to associate IPv4 address of a device with the MAC address of the device LAN card. So the problem is, say, for example, like in the topology I have here, say PC1 will send data to, say, PC2. Okay, so initially when a sender sends data, it doesn't know the destination MAC. This is the big challenge. Doesn't know the destination MAC, and this is the reason why first thing PC1 will do is to send an ARP request. So like in this scenario, the one that will reply for the ARP is R1. So R1 will send an ARP reply. It will send its MAC address, and that is the one to be added here in the destination MAC address. ARP. So again, ARP is used to determine the destination MAC address of a local device when it knows its IPv4. It provides two basic functions, resolving IPv4 address to MAC address, and a way for a sender to not always send the ARP request. It builds an ARP table stored in the cache memory. In the ARP table, this is where we see the binding of the IPv4 and the MAC address of the end devices. To send the frame, a device will search its ARP table for destination IPv4 address and a corresponding MAC. So let's say if the packet's destination IPv4 is on the same network, the device will search the ARP table for the destination IPv4. If it's on a different network, then it will search in the ARP table the IPv4 address of the default gateway. If the device locates the IPv4, its corresponding MAC address is used as the destination MAC address in the frame. And if there's no ARP table entry found, then it will send an ARP request. To remove the there's this clear command for the ARP if you want to remove entries from the ARP table, but there's this amount of time that it will age out in the cache memory. So entries in the ARP table are not permanent and usually removed as the time expires. The duration of the ARP cache timer differs depending on the operating system. And again, there's a command where you can manually remove the entries in the ARP table. This is the command for us to view the ARP table. In the command prompt, it's ARP-A, and for the router, it's show IP ARP. There are certain instances where this address resolution protocol, a layer 2 protocol, is being exploited. So there is a security issue revolving with the ARP. Among these are ARP broadcasting and ARP spoofing. You will encounter more on these different exploits in your information security. So like in the ARP broadcasting, what the attacker will do is to send many ARP requests or continuous ARP requests. Okay. So ARP requests are received and processed by every device on the local network, and then excessive ARP broadcast can cause some reduction performance. And then ARP replies can also be spoofed by a threat actor to perform an ARP poisoning attack. So a way to resolve ARP issues, you will learn that in your Cisco 3, there are sort of security measures you can do on the switch in order for the network infrastructure to be protected from these kinds of exploits. To sum it up, layer 2 physical addresses are used to deliver the data link frame with the encapsulated IP packet from one NIC to another NIC on the same network. If the destination IP address is on the same network, the destination MAC address will be that of the destination device. When the destination IP is on the remote network, the destination MAC address will be the address of the host default gateway. An IPv4 address uses ARP to determine the destination MAC address of a local device when it knows its IPv4 address. ARP provides basic two functions: resolving IPv4 to MAC addresses and maintaining a table of IPv4 to MAC address mappings. After the ARP reply is received, the device will add the IPv4 address and the corresponding MAC address to its ARP table. And for each device, an ARP cache timer removes ARP entries that have not been used for a specific period of time. IPv6 does not use ARP. It uses ND protocol to resolve MAC addresses. And an IPv6 device uses ICMPv6 neighbor discovery to determine the destination MAC address of a local device when it knows its IPv6. And this ends this chapter about ARP. I'd like to thank you for listening. Keep safe. Together we learn as one.